thanks for joining us today. I'm Lance. I'm a co-founder here at Flux, and I'm super excited. There's many faces I've seen before, so thanks for joining us today, and some new faces too. So happy to see that. So I'm just gonna hit present, and then hopefully you guys can see this. Is that working?
Yeah.
So I'm just gonna do a quick intro, kind of give you an idea of what Flux is, and then we're going to jump into a product demo, which can be interactive too. So you'll be able to follow along if you like, and it's going to be really fun. So I'll give a brief intro. I'll talk about the goals for today. Building a simple PCB. Then we'll get into the demo and do some QA. And then, we'll hang around as long as you guys want to hang around. So I'm down to chat, answer questions, hear about what you're working on. It's Friday, so I'm ready to chill. So what is Flux? It's a browser-based electronics design tool. And we've been working on this for about 2 years now, which I can't believe sometimes. It feels like yesterday we took on this pretty big task of moving and integrating a lot of these tools for creating electronics into the browser and stitching all these workflows together, just through frustrations in the industry. So I'm a former aerospace engineer. My co-founder did hardware at Apple, and the other co-founder was at Facebook for many years. And so we took a look at we interviewed a lot of electrical engineers and just to get a sense of like what the problems were in the current hardware development flow. And these were some of my favorite quotes and just some of the themes that we saw, and maybe some of these resonate with you. Just that there's separate tools if you want to do simulations, schematic design, PCB layout. There's often a lot of exporting, importing. Collaboration, especially when you're working with mechanical engineers, tends to be kind of difficult. You have to start projects from scratch. It's hard to reuse work that you've done in the past. Checking for errors can be difficult. Sharing PCB layouts, part sourcing can be a huge pain in the butt, as many of you all know, especially with our supply chain issues that we're experiencing now. Laying out traces, and just getting to the end of a project and realizing that the parts that you were using were out of stock, and you kind of need to hit the drawing board again. It's also kind of a pain. So these are, what we're trying to enable with Flux, these 3 things. So number 1, we are integrating a lot of these pieces of the electronics design workflow. So from part sourcing, schematic capture, simulation, laying out a PCB, in a way that everything can stay in sync. And if you're on a team, everybody knows what the source of truth is. There's not any confusion about what version you're working on. And second thing here is just enabling modern collaboration. So in software, you have GitHub. In design, you have Figma. And in hardware, there are some solutions, but I wouldn't say there's a fantastically modern solution that enables collaboration. So, we think that can be done a lot better with version control, commenting, enabling real-time design reviews, things like that. And then the third thing here is just this concept of reusability. Like, you should never have to start from scratch, and you should be able to leverage the work of other people. So, like GitHub enabled, you should be able to work on the shoulders of others. And this creates a lot of interesting compounding effects. And for those of you who were at our December event last year, we announced a first version of a PCB editor that works in the browser. It's real-time collaborative. It's pretty exciting. We're proud of it. And we also recognize it's in the early stages. And so we're looking, a big part of our philosophy is being community driven. So we like to put on events like this to capture your feedback to help shape the vision. And we thought it'd be really fun to get feedback while creating a really simple PCB. So this is why we're here today. We're going to design and manufacture a simple PCB all the way end to end in Flux. And so for absolute beginners, it might be a little bit difficult. I think a prerequisite is a bit of electrical engineering background. So we're not going to dive into how to design a functional schematic. I think you need a little bit of knowledge there to get started. Although we will provide like a reference design you can pretty much copy, just to move through all the stages. And this is session 1 of a 4-week session. So we're kind of breaking down each phase of the design process so that we can dive in a little bit more detail and answer any questions you might have, that kind of stuff. And of course, we'll be recording these sessions so that you can play them back on your own, and everybody will have access to everything you see here today. So don't feel like you have to take crazy notes or anything. So there's 2 paths. So just pick your own adventure. Path number 1, you can use a reference design that we have for a transistor switch relay. And so you're essentially just copying the reference design, going through step by step. And then path number 2, many of you have put projects that you want to build in the Slack community. I think I remember seeing one that was fixing your 3D printer because this custom PCB was no longer being manufactured. So maybe there's a way to reverse engineer it. And so, projects like that, I think is really cool. I think it's also important to just be realistic about what the tool can do right now. So I would choose a project that contains around 10 parts, something in that ballpark. It's possible to do more than that. But that's kind of what we recommend starting off with, just to get your bearings. And then something that we're working on right now but don't have shipped, we don't have fills or keep outs or polygons. So keeping it pretty basic with the traces. And then using KiCad parts and avoiding custom footprints. Again, you can create custom footprints, but the workflow is like not as smooth as we want it to be right now. So if you're going to design your own simple PCB, this is kind of what we recommend. And then here you can see on the right, example that Jarwin, who's our resident EE master, built and manufactured. And you did this pretty quickly. Cool. And then just to make this like a fun thing, we thought it would be cool to give the first 3 people who manufacture a PCB, meaning like they export the Gerber, upload it to JLPCB, and then get a board in hand. And the first 3 people who do that, we're going to give you some free swag. So we have this jacket that's like a holographic rain jacket. We thought it was pretty cool. Hopefully you think it's cool. Maybe it's useful for directing traffic, whatever you want to do with it. So yeah, first 3 people, just tweet at us a photo of your board and a link to your Flux project, and we'll send you some treats. So just to give you a sense of the timeline here, so the kickoff today, I just gave the high level intro. We're going to talk about parts and how they work in Flux and all the different crazy things you can do with nesting and making your own parts and forking and reusing other people's parts. So there's a lot to dig in there. And then next Friday, we're going to talk about just drawing the schematic. We're going to go over hotkeys and little tricks to help make your workflow faster. And then we may tackle simulation as well there. Just do a simple simulation so you kind of get the hang of how all that works. And then our 3rd session, we'll talk about laying out the PCB. So how do you create a layout? How do you control the size of the board? Do a custom board? Basic intro, navigation to the 3D editor, 2D editor. How do you position parts relative to each other? How do you handle routing on multi-layer boards? For our example, it's going to be, I think, a 2 or a 4-layer board, something like that. So it's going to be pretty simple, but we can't handle, basically infinite, I think up to 8-layer boards. And then the fourth session here, we're going to talk about ordering, sourcing, assembly, checking for manufacturability, how to do your Gerber export, working with manufacturers, and then we're going to assemble the PCB, using a little setup rig that Jarwin has there. Cool. So I thought it might be helpful just to start kind of at a high level about how parts work in Flux and how it might be different than other tools that you may be familiar with, whether it's KiCad, Altium, EZDA. So what is a part? So many of you might think a part is, it's a symbol. It might have a name, a description associated with it. You might have a footprint. You may even have a 3D model. But with Flux, we allow you to basically add any asset you want to a part. So this is fully customizable. So it's a little bit different than other platforms. So we allow you to add infinite properties, whether it be a part manufacturer number, other physical factors like resistance, and then you can add documentation links. You can add alternative parts or backups, basically anything you want. And there's also simulator code that's associated with a part. So Flux also has a programmable simulator that works right in the browser. So there's an IDE in the browser that allows you to create your own models, fork other people's models, and this enables some very powerful workflows. And there's also this concept of parts are able to be published to the community library. So similar to GitHub, you can publish your work, and you can also fork other people's work. You can see a version history behind that part as well. And then there's also real-time pricing and availability. So if you have a manufacturer number in there, you can actually see if something is available in real time. So we're plugged into these different manufacturers, and that's what they're saying in real time. It's kind of cool. And then the other concept to understand is that all parts you can nest parts within parts. So parts can have an internal schematic diagram. They can also have what's called a sub layout, and these are the things that create these compounding effects. So you can create modules that have internal schematics, so they can work kind of at a module or systems level. And so that can enable some really cool workflows as well. And another concept is like when you publish, every document that's using that part will get updated if they so choose. So we're working on a publishing workflow where you'll be able to preview the changes, accept the updates, so that everyone can stay in sync. That's kind of cool. So like I said, you can create these blocks that are shareable, they're reusable. So if you find yourself doing something again and again, maybe you can create a block for that, and utilize the power of nesting here. So here we have like a very simple schematic using these sub layouts modules, and that's what they look like underneath there. And we have a video of creating it's way more complex of a PCB than we'll do today. But essentially like stitching all this together and creating a PCB much faster and more reliably, because you can kind of ensure that each one of these sub layouts is manufacturable and robust. So yeah, that's pretty cool. So I just wanted to explain these at a conceptual level before we jump into the product, because sometimes it's hard to understand what's going on there. So hopefully that's helpful. So cool. Now we're just going to jump into the demo. So I'll say if you have, hopefully everyone has been able to create an account with Flux and get in. We've had some sign in and account issues. So if you're the one of those people who've experienced that, apologies. And if you're in the Slack, just like let us know and we can help you through that. But if you sign into your account and you can follow along, you know, with the demo here live, then obviously like we're recording it, so you can go back and do it on your own. So here it is. This is the transistor switch relay. Very, very simple schematic. Many of you probably understand it instantly. So we're just going to show you how to search for parts and how to modify or configure them if you so choose. And then we're going to show you how to import a new part from scratch and get the symbol, the footprint, the 3D model, basically everything that you need so that you can do it on your own. And with that, I'm going to hand it over to Jarwin. Oh, and I should say, by the way, if you have questions, use the chat. So chat, Archie's going to be responding to that and helping us prioritize, and we will do our best to get to all of your questions. Cool.
Okay. Yeah. Thank you, Lance. So yeah, I am Jarwin. I'm the Philippines. I am the product specialist here at Flux. During my free time, I tend to track satellites, talk to astronauts sometimes. If you are not aware, you could talk to the astronaut. So as long as you know the frequency they are talking to, yeah, you could talk to them. So yeah, I build my own satellite antenna tracker that is like linked to the NASA server. That is like, if I just click on the satellite, you know, that antenna will just going to track that from horizon to horizon. So those are just my quick background. So yeah, let me just share my screen quickly here, and let's just get into this one right away. So can you see my screen here, guys? And Lance, can you hear me clear?
Yeah.
Okay. So yeah, let's start to actually like create this project. So let me just explain this project a little bit. You guys know already about this one as you know, as the first glance. So yeah, this is a very basic transistor switch relay that could actually it's a high power because it's using a relay that could actually handle 10 amperes of AC. And yeah, we have something like very basic here. Just pushing the switch will will trigger the base current of this transistor, and that will actually like close the collector and emitter, switching on the coil. And we have also like a flywheel diode here to avoid any reverse voltage stored on that coil once it's turned on. Turn off. So yeah, so we're going to add all of the parts here, starting from the top right, the screw terminal block up to the battery here. So let's start a new project. So to start a new project, I need to click here on the Flux logo here, on the top left, and click new project. And right away, Flux will going to create a new project for you, and it will actually create a random name to it. You can actually change that one now or keep it as is. And as you can see here, we have the left panel wherein that's where you're going to search for the part, and also on the right side, that's the right panel where you could see the information about the selected object on the canvas. So in here on the library panel, this is where you're going to search for the part. It could be specific. You could search for the exact manufacturer number, or just say something like, I need 1.8 forward voltage, and it would give you something. And by the way, let's remember that all of the parts present here on the library are all community generated. I am one of that community, and as you can see, I have a lot of parts already created in here. Some of them as 3D models, some of them as of their own footprint, and etc. So yeah, let's start first with the screw terminal here. So I'm just going to type in screw terminal 01-X0103 because this one is a 3-point screw terminal. And as you can see here, Flux showed me 4 parts. but I wanted to pay attention to the part that has a 3D model and footprint. And as you can see here, this last one here with the part number XY301V, it has a footprint indicated by this icon. And this one also has a 3D model. And it has a usage count of 7. You need to pay attention every time you add a part from here to your canvas that it has a footprint and 3D model. Later on, I'm going to tackle on how to add the footprint and 3D model. But yeah, for now, let's just drag this one to here to the canvas. And the next one will be the relay. This is a single pole dual throw 5 volts relay. So let's just add that one. SPDT SRD. Okay, there's one. And as you can see here, this one is also a special part. It is a special part because it has a simulation model. As you can see here, there's an icon, simulated, footprint, and 3D model. Let's add that one in here. And this one is again a very specific part because it has already a manufacturer part number tied to it. Okay, let's jump into this transistor. Okay, it's a BGT S8050. So I'm just going to search for S8050, and there are a bunch of similar query that showed S8050, but I'm interested on this one because it has a footprint and 3D models tied to it right away. So just drag that one here on the canvas. And that's also very specific. As you can see, it has a part number. Okay. Okay, what else here? Okay, the switch, the 1571563. Okay, let me search 151563. Okay, there you go here. Created by the username Basil. It has a usage count of 20. It has a footprint and 3D model. Okay, I'm good with that. I'm just going to drag that one here on the canvas. And then, yeah, battery. So let's go back here to the schematic. Okay, it's powered by 4.2 volts. So that is 18650 maybe, but I wanted to use 18650 because I have a bunch of them on my toolbox. So 18650 battery holder. Okay, so let me just drag that one in here. Okay, so now we have like most of the component here on the canvas, but if you wanted to verify if really this parts has a 3D model or footprint, you can actually do that one right away here. So right now we are on the schematic editor. If you want to see their footprint and 3D model, just click on the PCB editor here on the middle of your screen. And let's just wait for this one to load up. And as you can see, this is the battery holder, that's the switch, that's the transistor, and that's the relay, and that's the screw block. So everything is like they have their 3D model. If I wanted to make sure if they have like a footprint, just click on here, the 2D view, and let's just zoom in. And as you can see, yeah, they have their own footprint. This is the relay, this is the screw block, this is the push button switch. Okay, we're good. On this next thing here that I wanted to add, so we don't have the resistor, the LED yet, right? So I came up with, because Flux gave me a tool to create something, and I actually like utilize this one. So if you look here on the search bar here and just type in generic dash part template, I created bunch of parts that is not really specific. They are tied to a footprint. So as you can see here, these are my favorite sizes, 0201 up to 0805, because those are the only thing that I could solder using my hand. So those are my favorite. So, but I'm going to stick with the 0805 in here. So as you can see here, these are not specific. Why is it that? So let me just drag this one, this resistor, the R0805. And as you can see, this is also special because I made sure that all of them, most of them have simulation model. So every time you're going to use these parts here, it could be simulated. So let me drag this one in here on the canvas. And clearly, right away, you're going to see that there's no resistance, right? but I need to put the resistance in there so that if I need to simulate the circuit, the simulation from Flux will going to get this particular field here, the resistance. Okay, so that is like the resistance, and as you can see, there's no manufacturer number, the name, the data sheet. It's empty because this one is very generic. I use this one to actually like create a board very quickly. So just drag the package size that I want. So if you look at in here, there's 2 resistor and 1 LED. So I just need to copy this one and paste it in here. And I just need to change this resistance to 1K because the other one is 1K. Yeah. And for the LED, I'm going to stick up again with the same size, 0805. So I'm just going to scroll down in here and look for that LED 0805. And here, it's here. LED 0805. I'm going to drag that one in there. And again, you can see there's a property here that is like empty, but I need to input something in here because I want this one to be red, so it should be 1.8, the forward voltage. And again, that is like needed for the simulation to work later on. So, okay, so we have the resistor, 2 resistor and 1 LED. These are still generic. So I need to go to the LCSC, okay? So for this one, 130 ohms. Let me just, and by the way, I'm going to use LCSC here because I wanted to assemble, get this PCB from GL PCB, and I wanted to utilize their assembly. So I want all of the parts to be outsourced from LCSC. So 130 resistor, there is like 0805. We're doing this one. I mean, I don't know if you can actually like relate with this one. So 0805, 130 ohms. Okay, that's good. I'm just going to copy here the manufacturer part number, okay, and go back to my project, and I make sure that the R1 is selected, and pay attention here to the availability in pricing. It's because they don't link to anything else. They don't show any important details that like would be helpful for me. So as soon as I paste the part number here, the availability and pricing will going to kick in and give me the part availability. So this particular resistor that I just put the manufacturer part number is available in LCSC. It is 8,550 stock, and that's updated just an hour ago. And if we look back again to some of the parts here, for example, this screw block, the availability and pricing is showing something right away is because remember this screw block is very specific because it has a part number, while these resistor here are all generic, right? So let's just fill in the 1K resistor. So just need to replace this one. And look for the 1K, okay, here, 1K, okay, 0805, okay, I'm good with that. I'm going to copy this one again, go back here, and just paste it here. Let me just remove these spaces here, but still work. Yeah, there are a lot, 34,000 available. So yeah, I'm good with that. And while we are doing that one, we could actually like define this part very specific by actually like inputting the manufacturer name, the data sheet. So let's just go back and copy this one and paste it here. And the manufacturer is resistor.today. Oh, that's interesting. Resistor.today. Okay, what about tomorrow? Okay, so resistor.today. Okay, so on here, I want to just copy the datasheet link here. So I'm just going to copy. I right click and copy link address. And I want to just add that in here. So every time I'm going to revisit this project again, or maybe you wanted to verify, oh, am I using the same power rated resistor? I could just click click on the resistor, and you know, this one here was the resistor, I mean the datasheet already. I could just click on that and yeah, there you go. I have the datasheet URL already. So in this case here, the other one, let me just fill in this one quickly. Okay, TIO. Copy, then paste in here. And for the datasheet, again, I'm going to just copy and paste it here. Paste. Okay. Now this one is these are very specific already, as you can see, even though the part name links to it's being defined by the package code. This is I usually work, I just drag for example, in here, on this generic part template, I actually have a SOIC 8 package. I could just drag that one right away, and definitely it has no manufacturer part number yet, but I know that that is like the package that I want. It's just a matter of supplying the part number. But for this one, I don't need this one for this project. So let's stick with this one here. For the LED, okay, 1.8. 1.8 volts LED, a red one, 0805. And by the way, for anyone who is not aware about 0805 that I'm talking about here, it's actually the package size of a component. So in this case, the 0805 is the English system of units. So 08 means to say that 08 inches, and 05 is like that 05. So by the way, if you look at again here on the library, on the search library here, I just didn't just add the English units. I also added the metric. So you can see here 0805, that's 2012 on metric. So yeah. So let's search for that resistor. Okay, here, the light on. Okay, just need to copy this one here, paste it over here, light on, and the data sheet will be just going to copy in here and paste it here. I need to do this one every time I create a project so that later on I could just pick up right away the data sheet. Okay, so everything is already here except for the diode. This flywheel diode here, the IN4007. So that is the one that we're going to import from the KiCad library. So how to import apart from import apart Flux? So you just click here on the Flux logo and click on the import and select this one, KiCad parts. And I already prepared this one in advance. As you can see, this is the diode library from KiCad. So I just need to select that one and click it open. And let's just wait for Flux to actually process all of the parts, because this is a library. It composed of several diode, different kind of variants. But what I need is like the IN4007, which is included in here, the 1N401. So I just need to click on this button here, and Flux will going to create, or open up a new tab. And what we are seeing here, it's actually the imported part, the IN4001. But yeah, we're interested on 4007, which is part of this family here. So I'm just going to change this one to 7. Okay. And then, as you can see here, this is a diode. So a diode is composed of two terminals, right? The cathode and the anode. And this is it. You are looking at the internal schematic of a part. So every time you open up a project or a document and you see that this button here is active, that means to say this is a part. This is a part. It's considered as a part. If you go here on this project, you can see that the publish as a part is inactive. That's why this one is a project. So let's just focus here on this IN 4007. So just change the manufacturer part number. Okay, for me to supply everything here, I could actually just go to LCSC again. And okay, here, I could actually just pick this one right away. So 407, could just copy that one. Description. Oh, no. That is the project. Okay, sorry, it's here, should be here. Okay. For us to define this particular part to be very well defined, we need to add couple of properties here. But the most important thing here is the manufacturer part number and the designator prefix. To add more properties, click on manage and click add. So name, datasheet URL, and I guess that's it. So we just need to delete here. Okay. What's the manufacturer name of that? Okay, it's here. Okay. And the data sheet should be here. Okay, paste it here. Okay, we're all good. So, and by the way, so maybe you're asking me, why is it that this is considered as a part? Because, I'm just looking at two terminals here. Because you are inside a part, this is the internal schematic of this diode. Basically, it's just two terminal. So if we look here, the transistor, if I'm going to go inside the schematic diagram of this transistor, I could just right click and open, and as you can see, because it is a transistor and somebody else is already here, you can see that it composed of three terminals: collector, base, and emitter, because that's the internal schematic of a transistor. So that's how flux is being defined in Flux. So let's go back again here and let's verify if this part has a footprint, because we just imported that LIV, right? If you click on the PCB, the footprint is empty. If I activate the grid here, there's nothing, because we need to import the footprint as well as the 3D model. So how could we add a footprint in here? So if you go here, if you click on the empty part of the canvas, you can see there's an asset panel. And if you click on the manage, you can see that there's only one asset present here, which is like the symbol. Just the symbol. You can see here, it's just a symbol. So we could actually like change this symbol into something as long as it's SVG, PNG, or JPEG. Let's add now the footprint. And by the way, all of the file format that you need to know that is like being supported in Flux can be seen here for the 3D model and for the thumbnail, etc. Let's add the footprint here. And for the footprint, I'm going to use the KiCad underscore mode. Okay, and maybe many of you already aware about what is this. This is the package code of the diode that we're using, the SOD123F. Okay, let me add another one, which is like the step, which is the 3D model. So I'm going to add that one in here. And pay attention here that both of these assets has the same ID. This one here is the same ID. This one is also the same ID. So we need to make a differentiation here. So for me to actually like identify that this one is the 3D model, I just need to put 3D and underscore. Click done. And we're almost done here. Let's go to the PCB, okay? And as you can see, the canvas is empty. There's no footprint. So how could you add the footprint? You need to just right click here on the object tree panel. Need to click footprint. And as you can see, there's a footprint. But it's just actually a two circles on the top of each other because you need to link an asset. So now on here, while the footprint is active, look here on the object specific rule and click add. And I'm going to use the asset rule, click done, and I'm just going to select that footprint here. And right away, you could see the footprint's already been rendered. And on the bottom left of the canvas, this is how we manage the layer view of the PCB. So you click on the layers here, and I just want to hide the base and the mask so that I could just see the pads here. So if I click here, this pad, this belongs to the cathode, and this one belongs to the anode. Now, the next thing is to add the 3D model. If we click on the 3D here, nothing is being, there's no 3D model. So we just need to add a new one. I mean, a new model node. So to do that, you just right click here on the root, click model, select the model, and then click add again here, call again the asset. And from here, this is why we put a differentiation between the two assets. This one is the 3D model. So let's just select that one. And let's just select the 3D view. And as you can see, that's the 3D model of the diode. Let me turn off the grid here to make it more prominent. And yeah, it's aligned to that pad, also to that other ends here. Yep, it's aligned there. So yeah, we have now just created and imported the footprint for this particular part. Now it's just actually adding it up to this project. So IN407, as you can see here, there is the footprint and somebody else already forked it. So let's just drag that in here and let's just move that one here, somewhere here. That's the D1. Click on the PCB to verify. And this is it. This is the D1 here. Let me turn off the paste mask here. And this is the D1 here that we just created. Click on the 3D and let's just zoom in. Okay, yeah, that's it. So it's a matter of actually like connecting all of these things to align and be identical to this schematic that we just created. And yeah, I guess that is part of the next session. So I guess Lance, take the mic.
Okay, awesome. Thanks, Jarwin. I wanted to open it up if you guys had any questions for next like 5 minutes or so, and then we can start wrapping up and people can hang around if they want. Cool. Any questions out there? You can use the Zoom, or I think you can unmute yourself as long as you don't have crazy background noises.
Yeah, also if people have suggestions about the format, really trying to cater this to you guys out here and help you guys get onboarded, and get your own boards manufactured.
Hi, my name is Tim Johnson. Just want to say that was fantastic. That was it was really good to see something built from scratch. coming in new to a new GUI, it's kind of difficult to get the feel for what the flow of the tool is. So this was just super to see. Thank you for that.
Yeah, you're welcome. And
Slack.
like I said,
Appreciate
oh
it.
yeah, go ahead, Linz.
I think there's a little bit of lag. I was just saying thanks for the suggestions that you put in Slack. I think like part of this was inspired by a lot of what you recommended. So thanks.
Yeah, this is Ray Shane. I had mentioned this in the chat, but I'm still a little confused by it. You put together the whole circuit, and having done it before, you knew where it was placed. But I found it a little confusing not having the outline of the circuit board there while you were doing that. I'm not I don't electrical engineer background, so I might be I might be a little bit behind this, but without having the frame of the eventual circuit board, it kind of confused me.
Yeah, the green outline here is the actual frame in this case of the board.
Okay, but did you define that anywhere, or is that just a?
This is the default size. When he created the
Okay.
layout, you can change the size and shape of it. It can have really any shape you want, any size you want.
Okay,
He's
Thank
going
you.
to show that here now. So he's going to change the size here. There you go. Now it's too small.
well, that was my point. Is if I'm creating a new one that I haven't done before, how do I know how much room I have?
Yeah. And like you're selecting parts that may or may not fit on your board. Yeah. I think Jarwin, because he's like familiar with the parts, we just kind of started with the schematic and defining the parts that way, but it makes sense to think about your mechanical constraints as well at the beginning of the process. So I don't think you're wrong there. It's just, we're going to focus on like the laying out of the PCB and the sizing, maybe custom boards, that kind of stuff in future sessions.
Otherwise, it was excellent. I just had a little confusion with that. Thank you very much.
Yeah, it's a great question, though. We're also working on features that will like auto position your components and auto size your PCB board just to get you like started quicker, and get like a compact or like a more exploded layout going really quickly. But it's still things we're working on.
I just have a quick question. Is there a way to have a group of parts and share those parts with users, so when they search for parts, they're only looking in that folder or those, in that group?
Oh, you mean like a kind of like a own collection of parts, you mean, for yourself or for your team?
Exactly, for like a team. This way they don't have to search thousands of parts. They're only looking in a specific area.
Yeah, we don't have that yet. These are things we're working on. One way to accomplish it today is just by using hashtags, that works pretty well. But yeah, this is like something as we're like making now more progress with the core editor, that we're investing also more time into the actual, organization of the component library.
Yeah, I think Jarwin, you use hashtag to filter your generics, right?
Yeah. That's the same thing that I did here. Like for example, the one that we just created, the IN407, I just added up the hashtag Flux demo. If we search that one Flux demo in here, it will show up just one. Oh, by the way, there's a bug that shows up nothing, but yeah, there should be here. Now, let me just do something here. I guess I remember I created a couple of GST style connector. So if I just type in pound and then GST, oh, why is it that one? Let me just go here and go to the library, GST. Yeah, there you go. All of the parts that has a GST tags, hashtag will show up here.
There you go.
Except for this Adafruit here, because the query is looking for the pound key and also the word inside it. Might be.
Yeah. One word, since we add this about like, maybe permission management here too. The components that Jarwin is able to see are components that are either globally shared or shared specifically with him or his own ones, So if you want to just share within your team or just with like a teammate or so, then only these components will only be visible to the two of you. not to the rest of the world, you know. And that's kind of cool because, you know, you get this like hybrid kind of view where you can like use public components that somebody created, or just your internal components or your own ones.
Yep. We got Evo's question. What software stack is Flux being written in?
Yeah, it's you know, it's based on React. You know, for the canvas and the mechanical editor, we use WebGL. You know, so it's like hardware accelerated. Yeah.
Any other questions? Well, cool. So I could talk a little bit about next steps and sort of what to expect moving into the future and how to get support and all that kind of fun stuff for those of you who might be interested in the community. As Jarwin pulls up some of these cool examples here. Mind if I share screen real quick, Jarwin?
Yeah.
Unless it was something you wanted to, you're just showing cool stuff. That's cool too. So like I said, we'll be around for the next like 30 minutes to an hour. Anybody wants to hang out and we can help you out. So next steps, we're going to meet again on Friday, next Friday. And we'll also have a session. We'll have some office hours where we're just like hanging out and available for 2 hours on Wednesday. So if you get a chance and you're like working on your board and you get stuck and you need help or you just want to share what you're working on, feel free to come hang out. And the idea is to basically do what Jarwin did today. So you're gonna put all the parts on the canvas and import and create your own part, because I think it's good to understand how to do that. So define all the parts for that transistor switch relay. And then if you're working on your own custom project, which I think is really cool, then you would just go through the same process for that. And that'll put you in a good position for next time where we're going to, you know, draw out the rest of the schematic, maybe go through some simulation and just kind of go through the next steps there. So, and I just put a link on our Zoom chat there. That's an invitation for any of you who want to join the PCB testers channel that's on our Slack. And there people are talking about what they want to build, kind of sharing their progress and asking questions, that kind of stuff. So if you're into that, feel free to click that link. And yeah, I think that's it.